this last talk of the afternoon is by for Tectonics of the North American continent and the Cretaceous Paleogene boundary and the implications for terrestrial cause in the Great Cretaceous Paleogene extinction controversy.
Hi, I'm from the University of Texas at Austin, and this is my paper on the Cretaceous Paleogene tectonics in North America. And I have a lot of information to go through. I'm going to go through really quick here. But during the Cretaceous, dinosaurs had roamed the Earth, but by the Paleocene, 65 million years ago, mass extinction wiped out nearly 75% of life on Earth, including dinosaurs. In 1980, Drs. Lewis and Walter Alvarez discovered a layer of clay at several sites of the KT boundary, containing high levels of iridium as well as other exotic materials. Because iridium is rare on Earth's surface, the Alvarez team proposed the layer must have been formed by an extraterrestrial impact. So far, this has been the most widely accepted hypothesis. In 1981, however, Dr. Dewey McClain showed that Deccan Traps volcanism could have increased CO2 levels in the atmosphere, thereby causing the extinctions. For decades now, these two hypotheses have battled for top contender, yet neither has been chosen as the champion. This presentation will attempt to show that this is because it was neither an asteroid nor the Deccan Traps of India that caused the extinction 65 million years ago. In 1996, Dr. Charles Officer and Jake Page introduced another hypothesis that seems to have gone unnoticed in the KT extinction debate. In their book, The Great Dinosaur Extinction Controversy, they showed that not only were the Deccan Traps occurring in India, but massive volcanism was occurring throughout the world at that time. Particularly, they pointed out that large magmatic events were occurring in North America that were not only coeval with the extinctions, but also with the uplifting of the laramide orogeny and the disappearance of the Western Interior Seaway. However, as no exact mechanism had been found to account for the exotic mixing materials in the KT boundary layer, this hypothesis was largely dismissed. So my original question was, if an asteroid had struck the Earth at the same time that major magmatic and uplifting events were occurring on both sides of the world, could the asteroid have caused some sort of disturbance in the mantle to account for those events? That answer was clearly no. The laramide orogeny began about 80 million years ago and lasted to about 50. And in India, the KT boundary layer is found as a separate layer within the Deccan Traps layers of lava. And several studies have showed that the lava erupted 400,000 years and continued 400,000 years after the KP boundary layer was deposited. So my next question was, what exactly caused the laramide orogeny at the KP boundary? So I began to study the geologic formations of North America before, during, and after the KP boundary. Before the beginning of the laramide, Texas lay at the bottom of a shallow seaway that stretched from the Arctic Ocean to the Gulf, and this is known as the Western Interior Seaway. Before the laramide, bays and estuaries covered most of New Mexico, and Arizona actually consisted of the floodplains of that seaway. Most of the fossils found at the KT boundary in North America were animals that lived within or along the coast of that seaway. Officer and Page showed that the Western Interior Seaway was mostly gone by 65 million years ago. And the entire biosphere basically disappeared before the KT boundary. The laramide began around 80 and lasted until about 50. However, many of the major full-thrust events and magmatic events in North America occurred directly at the 65 million year old boundary. Officer and Page showed that the laramide magmatic trend had been dated between 69 and 64. In Texas today, roughly 2/3 of Texas sits on top of the Cretaceous shelf, while the rest of Texas sits on top of Paleocene and under sediments that filled in the Gulf as the laramide was uplifted to the west. In Arizona, recent evidence shows that the Kaibab Plateau, which was uplifted along with the Colorado Plateau, uplifted as early as 65 million years ago. And in Denver, a few scientists at the Denver Museum of Science published a book on the plants at the KT boundary, which many have claimed to be definitive evidence of an asteroid impact because the plants disappeared so rapidly and then recovered rapidly. However, Dr. Johnson and others at the Denver Museum also published another paper where they did a study on hundreds of drill cores in the Denver Basin, and this study clearly showed that the Pierre Shale, which was formed at the bottom of the Western Interior Seaway, was dated at 68 million years ago. Above that lies a layer of volcanic tuff. Above that, they find the 65 million year old boundary layer. and above that they find evidence of a rainforest. So this particular study shows that this part of that basin went from the bottom of sea to a mountainous rainforest in the 4 million years spanning the KT boundary itself. Salt Lake and the Great Salt Lake Desert of Utah was part of that salty sea wave that was trapped by the rapid uplifting of the Rockies. Many of the fossils that we find are found in Utah and Hells Creek, Montana. So then what caused the Laramide orogeny? One study shows that subduction of an oceanic plateau on the west coast between 85 to 65 million years ago caused tectonic wedging in the coast ranges, uplifting and thrusting in the Sierra Nevada batholith, and development of Rocky Mountain Laramide structures. So the Laramide orogeny is here redefined to include all late Cretaceous, early Tertiary, full thrust structures from the Pacific coast to the Rocky Mountains. So it is within the Franciscan that we find our clues to what really happened at the KT Mountain. The coast range of phyolite is the coast range of phyolite is here in green. Pokes out in some sections along here in California. And it is a piece of Jurassic Age oceanic crust that was uplifted on the continent, or thrust into the Sierra Nevada batholith here. The Great Valley sequence that sits on top of the ophiolite are sediments that were actually deposited while this ocean crust was still in the ocean. The Franciscan Melange is the blue here, and it lies structurally beneath the coast range of phyolite. And here we have the selenium block, this piece in here. So the Franciscan mostly consists of gray whack, greenstone, red radiolayer, chert. Some areas there's blue schist, serpentinite, and a lot of different stuff mixed in there together. So what exactly is the Franciscan? Again, the one study shows it was an oceanic plateau. Another study shows that the sandstone in the Franciscan is volcanic and is made up of the same greenstone that is found in the Permanente terrain. And this study shows that these rocks were deposited on the flanks of an oceanic ridge or plateau. Another study shows that the cherts found within the Franciscan are manganiferous and that they were actually formed on the flanks of a mid-ocean ridge. So manganese is known to emanate from hydrothermal vents on mid-ocean ridges today. Another study shows that a Jurassic Age hydrothermal vent community has been found within the Franciscan, which is similar to those found in the Galapagos Islands that contain tube worms and clams and crabs that lived off of the sulfur coming out of the vent. So it would seem that the Franciscan would show evidence of being a mid-ocean ridge and or ocean island plateau. But when exactly did it attempt to subduct North America? One study shows that the Calera limestone formation in the Franciscan was deposited on an oceanic rise and was transported northeast until it cruised to North America around 63 million years ago. Another study shows the uplift of the Franciscan and the extension of the upper plate, consisting of the coast range of phyolite and Great Valley sequence, occurred in the Cretaceous or the latest early Tertiary. Several other studies have shown Franciscan uplift coequal with graben formation in the coast range of phyolite at 65 million years ago. So there are several other studies that have shown that the selenium block, again this pink block right here, and the selenium block collided with the Franciscan. One study shows between 65 and 55, and others shows between 60 and 50, so between 65 and 50. However, more recent drill cores from SAFLOG have shown that the sediments on both sides of the selenium block were deposited. They're arcosic sandstones that were deposited as the selenium collided with the Franciscan, and they were dated between 64 and 70 million years. Los Angeles, Santa Barbara, and Ventura County are all sit right here on top of Cretaceous Paleocene sediments. As the selenium block collided with the Franciscan, this would have trapped a plateau within a back arc basin between the selenium block on the west and the subduction zone coast range of phyolite complex on the east. As the mid-ocean ridge and or hotspot was thrust beneath the continent, it would move into beneath the now downgoing plate, which would uplift the downgoing plate, and that is what caused this flat slab subduction that pushed the Laramide into the interior. This study shows that the Yellowstone mantle plume was actually an ocean plateau off the coast of California 65 million years ago, but by 50 it was beneath the continent. So I am suggesting that it is this event, the subduction of the Yellowstone mantle plume, that caused the uplifting of the west coast, the uplifting of the downgoing slab, and the uplifting that moved the layer 9 into the interior. This presentation will also suggest that it's this event that caused the KT boundary layer and the extinction of dinosaurs 65 million years ago. All the materials being used to describe the asteroid can also be explained by the closing off of this mid-ocean ridge and or hotspot on the west coast. Iridium, glass spherules, shock quartz, granite, oceanic basalt is all found on the west coast. As of today, the only piece of asteroid ever found is a small piece of rock that is found not in the Gulf, but in the North Pacific, in 65 million year old sediments just east of the Hawaiian Islands. This rock contained iridium, chromium, olivine. Again, all can be found on the west coast. One study shows that the osmium iridium grains have been found in the uplifted Josephina phyllite in Oregon and northern California, and that these grains are found throughout the Pacific from the Hawaiian Islands to Asia. So that's one of the things that the asteroid theory argues, that the iridium can have only come from outer space, but in fact it is indeed found on the west coast. The authors of this study suggest that the iridium was transported from the core mantle boundary region to the lithosphere in a mantle plume convection system. The Josephina phyllite was uplifted along with the larger coast range of phyllite. And that would be here, Josephina phyllite here. Chromium is also found in the Josephina phyllite all the way from Oregon into Washington, as well as olivine is also found. It's been shown that the glass spherules found in the KT boundary layer were altered oceanic basalt, which is why it's believed that the asteroid struck an ocean basin. These spherules contain high levels of iridium osmium, which are also attributed to the asteroid. However, glass spherules can also be created by volcanic processes, and iridium osmium is found in the ultramafic rocks of the Josephina phyllite. Shocked quartz can also be created by geological processes and is often found in uplifted phyllates. Charles Officer showed that shocked quartz was generated in the eruption of Toba, and deformation landmark is present in quartz grains in the Francis. Other evidence shows air bubbles trapped in amber showed that oxygen levels dropped from 35 parts per million at 67 to 27 parts per million at 65. Dr. Gerda Keller showed that foraminifera began disappearing in the record 500,000 years before the KP boundary, and those foraminifera are calcium body plankton that dissolve in high CO2 levels. So this could show that oxygen was decreasing in the atmosphere at the same time that carbon dioxide was increasing in the ocean, and that began before the KP boundary. Another study shows that sea levels dropped at 67 million years ago. There's a drop here. It's dropped at 67, but it returned to normal by 65. However, this was taken on the east coast. So my question was, could the uplifting that was happening on the west coast cause the appearance of lower sea levels on the east coast? Because as Miller suggests, he suggested it was caused by glaciation. But if sea levels had returned to normal by 65, then the sea wave would have also returned if it was simply due to glaciation. So clues to the real killer in the KP extinction event may be found in dinosaur eggshells at the KP boundary, because they contain high levels of selenium. Fine particle emissions in the Kilauea eruption showed high levels of iridium, selenium, arsenic, and fluoride, and suggested the iridium was released as iridium hexafluoride. If the iridium was somehow separated from hexafluoride, selenium hexafluoride is a poisonous gas that causes breathing difficulties and lung failure. So a poisonous gas would not show itself in the bones of dinosaurs, but it would be recorded in eggshells and in plants. This is a map from Dr. Charles Officer's book showing the selenium that is still in KP boundary soils today. And there are seleniferous plants all throughout the Great Plains that still cause trouble. If cattle eat these plants, they die. So it's still poisonous contaminant in KP boundary soils today. Also, there is a USGS selenium decontamination unit in those strange phyllates. So this is my map. This is a map of the dinosaur fossils before the KT boundary. And I want to back up one. There's the selenium. There's fossils, and that's what it looks like today. And this also shows where the fossils are now all uplifted in the Rocky Mountains. So I will not argue here whether there was actually an asteroid or not, but if an asteroid did strike the Gulf at 65 million years ago, it did not cause the uplifting of the ocean floor on the west coast, the uplifting of the laramide orogeny, the disappearance of the western interior seaway, the change in oxygen and CO2 levels, the drop in sea levels, the volcanism that was happening throughout the world at that time, or the extinctions that were already occurring hundreds of thousands of years before it hit. The evidence presented here will show that it was the subduction of a mid-ocean ridge and or ocean island plateau on the west coast of North America that did. This presentation will also suggest that the capture of this ridge on the west coast could cause a disturbance in the mantle, and as the western moving North American continent collided with the ridge to the west, a surge of activity along the mid-Atlantic ridge could have led to African India's rapid eastern progression at the KT boundary, thereby also leading to the formation of the Devon Trapezoid. And that is my presentation. Thank you very much for listening.
Aren't there other ridge trench encounters that don't lead to mass extinction?
There are, yes, definitely, but this one has to do more with the presence of the Yellowstone hotspot and the uplifting. It uplifted the Coast Ranger phyllite and the Josephine phyllite, so it was all one big massive event, but it would be the presence of the Yellowstone hotspot is what I'm suggesting.
So are they two different things, the hotspot and the ridge, or are you saying it could
Well, the
be
hotspot, it's my belief, I don't have evidence of it yet, but it's my belief that the hotspot was actually part of the mid-ocean ridge. So it was a plateau formed on a mid-ocean ridge. Yes.
I agree with you. The asteroid, explanation is too easy. It's like a literalized explanation for the Carolina base, if you're familiar with this phenomenon in the Carolinas. And I agree we had to search for something which is